All right, so what we are going to do today is work on solving the triangle. You guys are going to have a similar problem to this. Everybody's going to get some random values, and it's going to be your job to figure it out. But there involves a few steps. So there is a triangle constrained by the equations negative x plus 2y equals 5 and y equals negative 2x minus 5. And the points 3, 4, and 0, negative 5. Find the equations and domain to define this triangle. So that's our job. So I'm going to just do a quick sketch of what this thing looks like. So first I'm going to solve this for y equals mx plus b form. So I'm going to say that y equals 5 minus negative x is going to be 5 plus x. And then I'm going to divide both sides by 2. It might take you a few more steps than that to do that, but that's more or less what it looks like. So if I sketch this graph, I hope that we can see this red. If I sketch this graph, 5 halves is about 2.5, or exactly 2.5, 2.5. A slope of 1/2, it looks like this. This line, negative 5 with a slope of negative 2, a y-intercept of negative 5. Negative 5 and a slope of negative 2. Those are actually going to be perpendicular. So I have those two equations. And then the points 3, 4, and 0, 5. Well, 0, 5 is right here, so that's definitely on the line. And 3, 4, I'm going to make a guess. 1, 2, 3 is probably right up here. So I've got this other line, but I don't have the equation for it. So step 1, I'm going to find the equation of this dotted line. And there's a couple ways I could do it, but what the obvious way or the quick way is to realize, look, I've got 2 points, so I can use a 2-point formula. I know that the point 0, negative 5, and 3, 4 are on the graph. So the last equation, I'm going to call it y3, is negative 5 minus 4, negative 5 minus 4 over 0 minus 3, x minus, I'm going to use this as my x1 and y1 here, so x1 is 0 plus negative 5. That's my equation of my final line. I'm going to simplify this. That's negative 9 divided by negative 3 is going to give me a slope of 3x distributed minus 5. Boom, that makes sense. We only care about this equation if x is between 0 and 3. So 0 is less than or equal to x is less than or equal to 3. And if I do that, then that's the part that I care about, and the rest of this is going to get eliminated. So I have one of my sides already. So that's great. y3 is done. If I want to go back and find, let's call this red one y1, well, I already know the equation of it. So what I know is y1 is 5, well, let's write it in normal mx plus b form, 1/2 x plus 5 halves if, I don't know what that point is. That's my big question mark. But I do know that I only care about it up to at least 3. So I only care about it between some number, whatever number this is, this question mark here, to 3. So I'm gonna like turn this into a little Christmassy thing here. That way I know I need to go back and find that number, but the rest of it's all set. I could do the same thing for that green equation. We'll call this one y2. And I can say y2 is, well, it's negative 2x minus 5 if, and I only care about it, well, from this question mark to that point. At this point, the x-coordinate is 0. So I'm going to say it's the same question mark, less than or equal to x, less than or equal to 0. And so that you get rid of that. So what I need to do is find the x-coordinate of this spot here. Well, I have my two equations, and they're both, in this case, they're both set up in y equals mx plus b form, which is nice. So I can do my substitution and plug in one for the other and start solving. So basically, I'm going to say that negative 2x minus 5 is the same as 1/2 x plus 5 halves at that point. That's what I'm looking for. So now I solve. I'm going to move my 1/2 x over this way. That's going to become negative 5 halves. So I'm going to subtract 1/2 x from both sides. I'm going to get negative 5 halves x. And then I'm going to move my 5 over here, and that's 10/5. So I'm still going to say that, 10 halves. So that equals 15 halves. I look at this, and they're both being divided by 2, so I'm going to multiply by 2. And I'm going to divide this by negative 5, so I get x equals negative 3. So I just found out that this is negative 3. So really, I care about this from here to here. And so these are my answers. I'm going to show you this, how we're going to graph this on GeoGebra, but those are my answers right there.